Let's talk about the future of security. Imagine the world of post-quantum cryptography is this massive, powerful symphony orchestra. It's incredibly complex, and it's supposed to be absolutely unbreakable.
So this orchestra, right? It's playing these new security standards, things like Kyber and dilithium. But here's the thing, it has a critical weakness. For the music to be secure, for the whole thing to work, it needs a constant, endless supply of truly random ideas, what we in the biz call true randomness. Without that, the whole grand performance is just a house of cards. If an attacker can guess just one note ahead of time, they can predict the entire song, break the code, and the whole symphony just unravels.
So how do you fix that? What if the answer wasn't adding another violin or another cello to the orchestra? What if the key to saving this whole thing was a revolutionary hip-hop artist, a creative genius who can just spin perfect, unpredictable beats out of pure, raw chaos? Let's call this artist RPSS.
All right, so let's get into it. Let's break down this artist's unique creative process. We're going to see how this incredible mix of strict rules and wild improvisation actually works. And yeah, it has a technical name: the Random Permutation Sorting System.
See, our artist, RPSS, doesn't sit down with a pen and paper. They start with a complete mess, a jumble of disconnected words and ideas, which is really just a disordered list of numbers. Then they freestyle. They just keep shuffling and rearranging those ideas over and over and over until, bam, a perfectly clear, coherent theme emerges. And that moment of clarity? That's when the list is perfectly sorted.
Now this is where things get really, really cool. It turns out we can measure this artist's genius in two totally different ways. We can count the lyrics, the number of steps it takes to get to that sorted theme, or we can just time the whole performance from start to finish. And when you look at the data from these two measurements, you see something pretty amazing.
So on the one hand, you have the lyric count. Look at that curve on the left. It's smooth, it's predictable, it's reliable. It's like knowing a master's verse is going to have exactly 16 bars every single time. But then on the other hand, you have the freestyle duration, the total time it takes, and that thing is just wild. It's spiky, it's chaotic, it's completely different every single time, even when the artist is doing the exact same creative process.
And just how stable is that lyric count? Well, get this. The theoretical average number of lyrics was supposed to be 96.00. The actual experimental result, 95.9598. That's a difference of less than 0.05%. It's incredibly stable. This gives our artist a predictable mathematical backbone, even while their timing is completely off the rails.
So, how is that possible? How can one single system be both perfectly predictable and wildly chaotic at the very same time? Well, the answer is in the artist's secret formula. There's a fundamental principle that connects these two polar opposites.
And this is it, the composition law. Now, don't worry about the Greek letters. The idea behind it is just beautiful. What it says is that the final performance time is created when the artist's stable internal rhythm, their natural verse structure, takes all that raw, chaotic energy from the environment and systematically organizes it. It connects the predictable lyrics to the unpredictable timing. It's the theory that explains their art.
And where's all that chaotic energy coming from? It's the vibe of the venue. Or in computer terms, it's something called microarchitectural jitter. It's all the tiny, unpredictable delays inside your computer that we usually just think of as performance noise. Things like cache misses, pipeline stalls, you name it. But RPSS doesn't try to get rid of this noise, it harnesses it. It uses it as the main ingredient for inspiration.
And this just shows you how that chaos creates wildly different performance styles, or what the paper calls phenotypes. Depending on the vibe of the computer, the exact same process can lead to a long, drawn-out, fat performance, or maybe a more focused but spiky, skinny one, or even a super fast, ultra-skinny delivery if the environment is quiet.
Okay, so we have all this raw, messy, unpredictable energy. What do we do with it? How does that get turned into something perfectly uniform and actually useful? This is where our artist goes from the live stage into the recording studio. The technique is called modular reduction, but you can think of it as a modulo mix. The artist takes that long, messy live recording and they feed it into a kind of digital sampler. Now, this tool doesn't care how long the performance was. It only looks at its final value within a fixed 16-beat cycle. It literally just slices away all the chaos and keeps the perfect part. And the result is, well,
It's stunning. After this modulo mix, the fat, the skinny, and the ultra-skinny performances, all those different styles, they are all transformed into the exact same thing, a perfectly flat, uniform distribution. All the chaotic history of the performance just gets washed away, leaving nothing behind but a perfect 16-beat loop.
And we can actually measure this perfection. The deviation from a perfectly uniform rhythm is tiny. And here's the kicker. The fat performance, the one that came from the most chaotic environment, it actually produced the most perfect output, with a deviation of just 0.13%. More chaos in, more perfection out.
So we know the method works in all kinds of different environments. But what happens if someone actively tries to sabotage the performance? What happens when a heckler shows up?
To figure this out, an experiment was run that basically simulated a heckler. They intentionally stressed out the computer, forcing the operating system to constantly mess with the resources and completely disrupt the artist's flow while they were performing.
And this just brilliantly shows how resilient the system is. The heckler completely wrecks the raw timing. Its uniformity is destroyed. The chi-square score, which is a measure of randomness quality, explodes by 580%. But the final musical output, the perfect beat that comes out of the modulo mix, it is completely unfazed. The loss of randomness is less than 0.01%. The artist is totally heckler-proof.
So, let's bring it all back. What does this all mean for that grand symphony orchestra we started with? Well, this heckler-proof genius gives us a completely new foundation for security. It finally brings our revolutionary artist and that grand symphony together on the same stage. So let's just recap the whole thing. It starts with your computer's normal noise, its jitter, which we now know is a valuable source of chaos. Then, our RPS artist grabs that chaos, using its stable lyric count and its wild timing. Next, the modulo mix purifies that raw energy into perfect, uniform randomness. And the end result? You get an endless supply of top-tier cryptographic fuel, literally created from computational waste with no special hardware needed at all.
Ultimately, it really all comes down to this powerful idea from the paper. The composition law isn't just some abstract formula. It's the mathematical guarantee. It proves that we can create cryptographic purity directly from the chaos that just naturally emerges inside our computers every day.
And that kind of leaves us with one last really fascinating thought. For decades, we've treated computational noise as a problem, right? A flaw to be engineered away. But if that very same noise holds the key to perfect randomness, what other incredible secrets, what other powerful resources might just be hiding in the chaos of our own machines?